Good morning, grade 11. This is Miss Teresa. This is a video guide for the standard practice test for Chapter 4, Force. I hope you try to answer the practice paper first independently before watching this video. Question 1. A car of mass m travels in a straight line at a constant speed along a level road with a coefficient of friction between the tires and the road of mu and a drag force of t. The magnitude of the net force on the car is. Okay, so we know that we don't need to talk about the friction in chapter 4 and drag force because we didn't tackle that, but this is motion in a straight line at constant speed, and we're just being asked of the net force. Okay, so the car is moving at constant speed and you are being asked of the net force. What's the net force of something, of an object, when it's moving at a constant speed? Let's remember the static equilibrium. I'll just write equi here because equilibrium is such a long word, and dynamic equilibrium. Dynamic equilibrium. Okay, equilibrium. Alright, so for a static equilibrium, it's a state where an object is at rest, and of course, all the net forces are zero. In dynamic equilibrium, though, the object is already moving, but it has a constant velocity, it has a constant speed, and it's moving in one line, in a rectilinear motion, one dimension. So in both cases, the F net force is zero. Whether it's a static equilibrium or dynamic equilibrium, if there is a movement and it's constant speed, the net forces will be zero. So this is the answer. Question 2, a person stands on the surface of the earth. The mass of the person is m, and the mass of the earth is big M, capital M. The person jumps upward, reaching a maximum height h above the earth. When the person is at this height, okay, the magnitude of the force exerted on the earth by the person is. Okay, so we are just being asked of the force exerted by the person on the earth, and we know that Fg is equal to the weight of the person. Okay, and weight of the person is equal to mass of the person multiplied to the acceleration due to gravity. Okay, so the answer here is letter A only. Whether you're jumping or maybe flying, if you can fly, or whatever you're doing on earth, your force, okay, the magnitude of the force you exert on the earth is always mg. Question 4. The tornado is a carnival ride that consists of a hollow vertical cylinder that rotates rapidly about its vertical axis. As the tornado rotates, the riders are pressed against the inside of the wall of the cylinder by the rotation, and the floor of the cylinder drops away. The force that points upward, preventing the riders from falling downwards is. Okay, so your tendency to answer this is that you're going to choose normal force, because we know that if you are sitting, let's say, on a chair, then you're exerting a force towards the chair, and that's your weight Fg, and the chair is exerting also a force against Fg that is equal to it but opposite, and that's the normal force Fn. Okay, but in this case, that's not what's happening. It's a tornado carnival ride. I don't know what that is. I haven't been in one, but according to the explanation over here, it's a hollow vertical cylinder. So it's like this. It's hollow vertical cylinder, and as it will turn, I don't know, this way maybe, turn rapidly, so the person will be pressed against the sides of the cylinder. Another person will be here pressed against the side as it is turning vertically across this along this axis. Okay, so this will turn rapidly in this direction, and the people will be pressed against the walls, and then they will not fall down. Okay, but what force prevents them from falling down? Which is pointing upwards. Okay, we know that the FG of these people are pointing downwards. Okay, their weight. Now, what prevents them from falling down? It's not normal force, because normal force is always perpendicular to the point of contact. In this case, this one, the force pointing upwards in this case is the friction force, letter A. Okay, not normal force in this case. Why? Because this person is in contact with the wall of the tornado cylinder, and it's you're being pressed against the walls as you are being whirled around. So that is frictional force only. So your answer is A. Question 5. When a bus makes a sudden stop, passengers tend to jerk forward. Which of Newton's laws explain this? Newton's first law, Newton's second law, Newton's third law, or it cannot be explained by Newton's laws? So the answer here is Newton's first law. Newton's first law of motion is also called law of inertia. You have to remember that. And the tendency of an object to retain its normal motion, okay, is called inertia. Okay, so for example, you are in a bus, okay, and you're sitting down, okay, and you don't have your seat belt on, because most of the buses do not have seat belts. All right, now the movement of the bus is forward, and then suddenly if it stops, your tendency is to move forward, even though the bus already has stopped. Your body, the body of a person, okay, because especially if the person's not wearing seat belt, they tend to jerk forward or continue moving forward, and that is called your inertia. So the law of inertia is the first law of motion. Okay, the second law is the law of acceleration. Third law is law of action interaction. You should remember those things. It's all in PowerPoints that we have discussed in class. If you don't know where they are, actually they are in LMS, and also the screenshots were taken by your classmates. It's in your files in our group. Question 6. Only two forces, F1 and F2, are acting on a block. Which of the following can be the magnitude of the net force? F, acting on the block, indicate all possibilities. So what are the possibilities of the net force acting on the block? One of the possibilities is that both of the forces, F1 and F2, will be in the same direction, F1 and F2. Okay, so in this case, F in this case is equal to F1 plus F2, right? So in this case, if F1 plus F2, then this is greater than F1 plus F2 is greater than the F. All right, so it could be letter B, right? So that's our answer. Another possibility of the forces acting on the object could be that they are right angles to each other. Okay, F1 here and F2 here. The resultant force, the resultant will be over here. This is your F, resultant force. So in this case, there's nothing there in our choices. And lastly, we will have two forces acting opposite each other. F1 will be here and F2 will be here. So in this case, what will happen is that it's F1 minus F2, right? Or F2 minus F1. In this case, the resultant force will be less than F1 minus F2. Okay, so that could be letter C as well. So our answers, there are two answers over here, B and C. Question 10. If a cart sits motionless on level ground, there are no forces acting on the cart. True, false, or maybe. This will be false. Now we have to remember again our static equilibrium. Okay, static equilibrium. Equilibrium. Okay, in a static equilibrium, if something is not moving, there will be a forward force, just F in this case, and there will be frictional force acting against it, and in this case F is equal to the frictional force, therefore it's not moving forward or backwards. There is also your Fg, the weight, and the normal force Fn, and in this case Fg is equal to Fn, but just opposite, okay, just negative of each other, therefore they cancel out. So there are no forces acting on the cart. There are forces acting on the cart, but the net force is just 0. It doesn't mean that there are no forces, just that they cancel out each other. Question 11. An object whose mass is 0.092 kilogram is initially at rest and then attains a speed of 75.0 meters per second in 0.028 seconds. What average net force acted on the object during this time interval? So we have mass given here, which is equal to 0.0092 kilograms. And then we have initial velocity. Initially at rest, it says, so V initial, Vxo, is equal to, or just VO, because it's not specified if it's up or down, 0 meters per second. And then we have Vx, the final velocity, is equal to 75.0 meters per second, and the time interval given here is 0.028 seconds. What's the average net force? Okay, so the formula that we need for this is F is equal to mass times acceleration, but acceleration is not given. But the formula for acceleration is equal to A equals final velocity minus initial velocity, Vxo, divided by the time interval. So we have those things. Vx is 75 minus 0 divided by time is 0.028 seconds. So the acceleration in this case is equal to, let me just calculate, sorry about this, 75 divided by 0.028 is equal to 2678.57. Okay, let me just write that down, 2678.57. okay, and then we meter per second squared, and then we're going to use F is equal to mass times acceleration to find for the net force, average net force for this. Mass is 0.092 kilograms multiplied to 2678.57. So the F net in this case, net force, is equal to 246.43 newtons. And we need two significant figures for the answer, because the smallest significant figure here is 2. Therefore F net is equal to 2.5 multiplied to 10 raised to the power of 2 newtons, which is letter B. Question 13. Which of the following fundamental forces are not apparent to us in our everyday lives? So all of these A, B, C, and D are our fundamental forces, basic forces of nature. All right, but which ones can we not feel? Not apparent, meaning we cannot feel, we cannot see. So of course we will have strong nuclear forces and weak nuclear forces, because these are nuclear forces. These are just in the atomic level. Only atoms will be able to feel this or experience this in the atomic level. Very, very small but then they are strong and weak because of course they are clumping together. The force is taking in together the atoms, the fundamental parts of the atom, so it has to be strong and weak nuclear forces. We cannot feel these are just, that's the explanation. Question 14. An SUV of mass 3,250 kilograms has a head-on collision with a 1,250 kilogram subcompact. Identify all the statements that are incorrect. So there is an SUV over here which is 3,250 kg, and it has a head-on collision with a subcompact, another type of car, which is 1,250 kilograms. Okay, so they collided with each other. Alright, identify all the statements that are incorrect, meaning false. Alright, so letter A, let's analyze this. The SUV exerts a larger force on the subcompact than the subcompact exerts on the SUV. So how do we know if the force is larger or smaller? It also, because F is equal to ma, so depends on the mass and acceleration. And since acceleration is not given in this, we don't know how fast the SUV is running. We don't know how fast the subcompact is running as well, SC subcompact. So we don't know that because force depends on both mass and acceleration. How about if the SC is faster than the SUV, much faster? We don't know that. So we can say that A is false. Then how about B? The subcompact exerts a larger force on the SUV than the SUV exerts on the subcompact. Same, because we don't know the acceleration. This will be false as well. Letter C, the subcompact experiences a larger acceleration than the SUV. Subcompact experiences a larger acceleration than the SUV. So this will be true because F is inversely proportional to what? Force is inversely proportional to the mass of the object, but the acceleration is directly proportional to the magnitude of the net force. So the smaller the object, the larger is its acceleration inverse. Therefore, that is true. We cannot choose that. And the SUV experiences a larger acceleration of subcompact. That is false. So these three are the answers, A, B, and D. Question 15. Which one of the following statements is correct? Okay, in these types of questions, you have to remember, sometimes they are asking which is not correct. Okay, which is not correct, or which is false, which is not true. You have to look out for these for these words, not or false or true, because the tendency of students when they see questions like this is they find out which one is true, and that's the first mistake that you are going to commit if you are going to just dive into the question without reading what the question is asking about. Okay, so you have to look out for the negative words. Okay, not correct. But in this case, we are looking for which is correct. So you have to be careful with that as well. Okay, read the question properly. So which one is correct here? The gravitational force on an object is always directed upward. That is wrong. Okay, the gravitational force on an object is always directed downward. That is correct. What if there's another question, another choice which is correct? Let's read on. The gravitational force on an object depends on the vertical speed of the object. The gravitational force, not actually, because the gravitational force Fg is equal to m times g. No, it doesn't depend on the vertical speed. It only depends on mass and acceleration due to gravity, so this is wrong. The gravitational force on an object depends on the horizontal speed. That's also wrong because Fg is also just equal to mg, so letter B is our answer. Question 16. A normal force is a contact force that acts at the surface between two objects. Which of the following statements concerning the normal force is not correct? This is what I'm talking about. Okay, not correct this time. Okay, letter A, let's read. The normal force is always equal to the force of gravity. Is that correct? Is normal force, the upward motion, Fn, is it always equal to Fg? In this case, yes, in this situation. But how about if it's in an incline? Okay, and the Fg over here, the Fg is this way. This is your Fg. But the normal force is this way, Fn. Okay, why? Because Fn is always perpendicular to the point of contact. And that is not correct in this case. So this letter A is wrong, because in some cases, yes, they are equal, but in other cases, like this case over here that I just drew, they are not equal. The normal force is just large enough to keep the two objects from penetrating each other. This is correct. Normal force is not necessarily equal to the force of gravity. Correct, as I have explained in this situation. And the normal force is perpendicular to the plane of contact. Yes, normal force is always perpendicular to the plane of contact. So the answer for this question is letter A, because that is not correct statement. Read your questions. Always do this. Please do not answer blindly, or do not just answer according to what the others are answering, because the majority is answering this and this is their choice, this should be my choice as well. No, please trust your instincts. Do not just go with the flow. All right, so these are the only things that we didn't discuss. As a practice sheet, we discussed chapter 1 and chapter 2. If I have time, I would make videos about those, but chapter 3 and 4 are the most important ones that we need to discuss in a video. That's why I made videos for them first. Okay, so good luck with your exams. Have a nice day.